Welcome back guys to another video in the ICD-1 video series. In this video we're going to follow on from the previous video where we talked about the OSI model. So in this case I want to give you an example of how the OSI model can be used for network communication. In this example, the host on PCA has just pulled up a web browser and searched for the URL of google.com. What happens next? Okay, so at the moment the host has the name of the server, Google, but it doesn't have the IP address of the server. From a previous video, we know that devices use their IP addresses to communicate in different networks. So it's the IP address which allows for end-to-end communication. So because host A doesn't have the IP address of the server, it doesn't know how to reach the server. So it can't communicate with it yet. So host A has to use the domain name system to resolve the host name into its IP address. So the way it works is the host A will send a DNS request to its DNS server, which probably resolves in the ISP's network. And this DNS request says, if you know the host name, if you know the IP address of Google, please send me it. The DNS server will respond back and say, okay, here is the IP address for the device that has the host name Google. In this case, it's going to be 2.2.2.2, and host is going to have the IP address 1.1.1.1. So now communication can actually start. The first thing the application is going to do is going to build the data it needs to send to the server. This is our data. It's going to send to the server. And so, like I said before, the browser is going to request a web page from the web server. How does it do that? Well, HTTP is a protocol which defines how a web browser can interact with a web server, and it defines that when we want to request a web page from a web server, we have to use the HTTP GET request. That GET request will list the file that we're trying to request so that we can display it on our web browser window. So at the application layer, we're actually going to send a GET request. Then at the presentation layer, we're going to format and structure that GET request in a way that server B can understand and will be able to read it. Then at the session layer, we establish a connection between PCA and server B, between the applications more specifically. So far, we've defined that we want to send a GET request, we've defined the format of the data, and we've defined that we want to establish a connection. So now we move into the transport layer. From the transport layer onwards, that's when we start adding information. We start encapsulating the data in additional headers, so we can add information to the data to ensure that it arrives successfully at the target device. So by headers, I mean additional information so that we ensure that this data gets to the correct device. So now we're going to establish a TCP connection between these two devices. So a TCP connection is established between these two devices, and what's called a socket is established on both ends to ensure that this TCP connection is unique when compared to other TCP connections. So in this case, let's say that the web browser randomly generated the port number of 1000, and we know the HTTP uses the port number of 80. The socket on this side will say that the IP address is 1.1.1.1. The protocol we're going to use to send data is TCP, and we're going to use port number 1000. The socket on this side will list the IP address of 2.2.2.2, the protocol of TCP, and the port number of 80. By using a socket on either side, it ensures the TCP connection stays unique. So we're going to use TCP to send this data because HTTP uses TCP, and TCP ensures data is sent in a reliable fashion. So what that means is that as PCA sends data to server B will acknowledge receipt of the data. Any data that's dropped will be resent. So we're going to add on a transport header, and we're going to add the protocol of TCP and the source and destination ports we're going to be using. So source port of 1000, destination port of 80. So now we need to define who this data is going to be sent to end-to-end. We need to define the end-to-end communication. So we need to define the destination IP address, who this packet should eventually end up at, who this data should eventually end up at. So we add on a network header. This network header will list the source IP address and the destination IP address. Source IP address will be all ones, destination IP address will be all twos. So we're saying that we want to send data from this source, and we want that data to eventually end up at this destination device. So we've defined who is going to and who's coming from, who's going to end. Now we need to define the next device in line that we need to send this data to in order for it to eventually arrive at server B. Remember, host A and server B are not directly connected. There's no direct connection between them. They're in separate networks. So we have to use another device in order to reach server B. Now host A needs to think about what device it needs to use that connects to its local area network in order to reach server B. In this case, it's going to be its router. So because this is an Ethernet network, these devices have Ethernet IP addresses. Host A has the MAC address of all A's. Router has a MAC address of all B's. So we'll actually add a data link header and trailer, which will list the source MAC of all A's and the destination MAC of all B's. So now host A has enough information in order to send this data to server B and to get this data to server B. So now at the physical layer, we actually put this data onto the link and transmit this data to the router. The router will receive this data and see, oh, okay, this data is meant for me. So I'm going to de-encapsulate, which means that to remove a header to reveal a header below. So in this case, we'll remove the data link header to reveal the information at the network layer, at the network header. And he says, oh, okay, this packet isn't actually meant for me. Host A is just trying to go through me to reach the destination IP address of 2.2.2.2. I'm going to look at my routing table and see how to reach 2.2.2.2 so I can send the packet to the next device in line. This process continues until the data reaches server B, in which case server B will now send data back. It will send back the web page. It will send back the data reliably is the protocol TCP source and destination ports, source port of 80, destination port of 1000, source IP of 2.2.2.2, destination port or destination IP of 1.1.1, and a source and destination MAC based on its MAC address and the router's MAC address. So as you can see, when we tie all these concepts together, it's not difficult to see how the OSI model can be used for network communication. Each layer defines additional information that the host must add to the data in order for the data to get to the correct destination successfully on time. So what we're going to do in the next video is we're going to actually look more in depth at the main protocols of the OSI model: Ethernet, IP, TCP and UDP. I hope this has been informative for you, and I would like to thank you for viewing.